All right, so good morning. Today we're going over chapter 7, section 4, adding and subtracting polynomials. So when you add and subtract your fractions, remember you have to have like denominators. We've done these all the time with normal fractions. Now the only difference is instead of being a number at the denominator, it's going to be a number and a variable, or a number and a variable plus another variable. It's just going to be a polynomial at the bottom. Now in this case, you have a over c plus b over c equals a plus b over c. So just like normal fractions, the c stays the same. We add the tops. And when it comes to subtraction, we're going to do a minus b, so we subtract the tops, and the c stays the same. Now it's going to be the same as if we were to be doing 7 plus 3 over 5 over 5. The 5 stays the same as we are left with 10 over 5, which will simplify to 2. Now, if we do it the other way, I'm going to keep the same numbers, 7 minus 3, both of them over 5, because we have the same c. As long as it's not 0, you can go ahead and just do 7 minus 3, which is 4 over 5, and that will be your final answer. So just like you usually do with normal fractions, the denominator stays the same. You go ahead and add the top like you usually would, or subtract it, but again, keeping the denominator the same. The only difference is instead of a number, you're going to have a polynomial. So, for example, this one we have adding and subtracting like denominators, or with like denominators. You notice the 4x is exactly the same at the bottom. It's just going to be a polynomial. So if we were to add or subtract like we normally would, this would end up looking at 7 plus 3, all of it over 4x. Which is just going to end up simplifying to 10 over 4x. Now you can simplify this by 2's because 10 and 4 are both divisible by 2's. So we end up with 5 over 2x as your most simplified answer. But overall, when you add them, the 4x stays the same. I'm going to put these two as the final answer. Now, ideally, the most simplified one would be the most correct. And now going on for b, again, we have the same denominator of x plus 6 on both of them. So I can just go ahead and write 2x minus 5 over x plus 6. And there's absolutely nothing I can do to that equation or to that term to simplify it. So that would be your final answer. Just a 2x minus 5 over x plus 6. So in order to do the first one, we notice that 12x is already the same denominator. So we can just go ahead and subtract 8 minus 5, which is 3. So we get 3 over 12x. Now this can be simplified by 3 as the numerator and the denominator both fit into it. So we get 3 divided by 1 is 3. 12 divided by 3 is 4, so our answer is 1 over 4x for number 1. For number 2, again, we have the same denominator, so we can go ahead and just add the 2 plus the 1, so we get 3 over 3x squared. But because the 3 have a 3 on the top and a 3 on the bottom, this can be simplified into 1 over x squared. Then for number 3, I can go ahead and subtract the 4x minus x since we have the same denominator. So we're going to get 3x over x minus 2. And that's going to be our answer because there's nothing we can do to simplify it. And for the fourth one, we again have the same denominator of x squared plus 1. So I can go ahead and just write 2x squared plus 2 over x squared plus 1. But you can actually simplify this. We have a greatest common factor in the numerator. So I can go ahead and take out a 2 to get 2. X squared plus 1 at the top. X squared plus 1 at the bottom. Which if you notice, they're the exact same terms, so they will cancel out. So you're just left with 2 over 1, which simplifies to 2 as your final answer. Now adding or subtracting with unlike denominators. We have the example of, let A, B, C, and D be expressions with C not equaling to 0 and D not equaling to 0. You have A over C plus B over D equals AD over CD plus BC over CD. So you end up adding AD plus BC over CD. Now again, this is something you've done before with numbers. So let's say I'm going to use the same expression as before. So 7 over 3 plus 3 over 2. We can't add these fractions because they're on like denominators. Usually you would multiply the greatest common factor, the least common factor, or a factor to give you the same denominator. In this case, I'm going to multiply this first equation by 2 over 2 and this second equation by 3 over 3 to give me the same denominator. So I will end up with 14 over 6 plus 9 over 6, which is going to simplify to 23 over 6, and that will be our final answer. So you always cross multiply. If you notice, for these small numbers, I could have just cross multiply like this, and I would have gotten the same thing, which is what they do up here. They cross multiply these two with these two. Same thing for the subtraction. You want to multiply the denominators to make sure you have the same denominator in both of them in order for you to add or subtract. Now let's look at the paragraph. You can always find a common denominator of two rational expressions by multiplying the denominators as shown above. However, when you use a least common denominator, or LCD, which is the least common multiple, LCM, of the denominators, simplify your answer may take fewer steps. Since we're dealing with polynomials, a lot of the times you're not going to be able to tell right off the bat what is the least common denominator. So you're going to end up cross-multiplying a lot, which is fine. It happens a lot, most of the times, most likely. And yeah, when we simplify, it's going to take a little longer, but we're still going to end up with the exact same answer at the very end. They want us to find the least common multiple of 4x squared minus 16 and 6x squared minus 24x plus 24. Now, to find the least common multiple, we're probably going to have to factor it out to see what are the common factors for both of these terms. Now, we have the advantage of this first one, that is a perfect polynomial. If you don't remember how to simplify a perfect polynomial, that's fine. We can take out the greatest common factor, or we can go ahead and take it as the greatest as a polynomial. It's a perfect square. Now I'll do it taking out the greatest common factor first. So you end up with 4x minus 2 and then x plus 2 for this first term. And then for the second, I am going to take out a 6 because it's a factor of all of them. So x squared minus 4x plus 4. So we end up with 6 x parentheses, x parentheses. We're going to end up with a negative minus 2 and minus 2 just because we want to make sure they multiply to positive 4 and they add up to negative 4. You guys remember the rule. And then we notice we have a common term. Our least common factor for these two are x minus 2. But the only way for us to figure it out was to get, so x minus 2 is our least common multiple. And we have to factor it to figure it out. So like I was saying earlier, you can either cross multiply, which is what I'm going to choose to do. And then, or you can get the least common multiple and multiply it by that. And you should get the same thing. Now I'm going to go ahead and just cross multiply. So I'm going to get 7 at the top. 3x squared plus 3x plus, now I'm going to get 9x squared times x. All of that is going to be over 9x squared, 3x squared plus 3x, all of it multiplied. Now, here's when the simplifying comes in, because technically this is set up already to be able to add it. But I need to go ahead and multiply things in order to figure out what's going on. So that's going to become 7 times 3 is 21x squared. And then plus 21x plus 9x cubed. I'm going to go ahead and do the bottom. So I'm going to get 27x to the 4th power plus 27 x to the third power. I'm going to rearrange it into standard form, the top as the bottom is already in standard form. So I'm going to end up with 9x cubed plus 21x squared plus 21x over 27x to the fourth plus 27x to the third. Now, I would recommend you choose one, the numerator or the denominator, and start working on it. I don't ever recommend you guys doing both at the same time. I know you guys may be capable of it, and that's awesome. But if you do it one at a time, it's going to make it a lot easier, as that way you don't have to worry about which one goes where often. So I'm going to start with the numerator. We'll do the denominator after. So solving for the numerator, I'm going to take out the greatest common factor, which in this case is, I think it's a 3x. Let's try it out. So taking out 3x, I'm left with 3x squared plus 7x plus 7. Now, the 3x squared plus 7x plus 7 is a prime polynomial, so I'm just going to leave it the way it is for now and go ahead and I'm going to do the denominator. Taking the greatest common factor of 27x cubed. So I'm left with x plus 1 at the bottom. We're actually able to simplify the outside of the parentheses, the 3 and the 27. The 3 becomes 1, 27 becomes 9. The x disappears, this becomes an x squared. So I'm left with a numerator of 3x squared plus 7x plus 7 over 9x squared x plus 1. You guys can leave it like this. You can multiply the 9 into the x plus 1 again. There's really no need, since this is the most simplified this equation is going to get. For this one, we're going to, again, cross simplify. So we're going to get x plus 2, parentheses, x squared minus 4x plus 3, minus, parentheses, negative 2x minus 1, 2x minus 2, all of that over 2x minus 2, x squared minus 4x plus 3. Now, a few things I want to mention before we go ahead and multiply everything. This negative right here is this minus sign. Because it's a polynomial, we're going to have to distribute the negative after we get the term in order to make it easier on ourselves to get the final answer. Now that I mentioned it, let's go ahead and distribute everything and see what we have. I'm going to start with the numerator and do the denominator at the very end. So I'm going to go ahead and start distributing. So I'm going to get x cubed minus 4x squared plus 3x plus 2x squared minus 8x plus 6 minus, and I'm going to keep the parentheses until I distribute it. I'm going to go ahead and distribute these terms. So negative 4x squared plus 4x minus 2x plus 2. Again, I'm not writing the numerator yet. I'm going to write that at the very end. I'm going to go ahead and distribute that negative and combine the like terms on the before the negative as I can. So we have the x cubed. We have these two which are squares, so it's going to become negative 2x squared. We have this 3x and this negative 8x, which is negative 5x plus 6. Now I'm going to go ahead and distribute the negative. It's going to become 4x squared minus 4x plus 2x minus 2. I'm going to go ahead and continue combining like terms for the numerator. So I get x cubed. So I get this squared, 4x squared, and negative 2x squared. That's going to give me a positive 2x squared. Then negative 4x, negative 5x, so negative 9x plus 2x minus 2. and then the plus 6, x cubed plus 2x squared minus 7x plus 4. I'm going to go ahead and write the new numerator that we have so far. So x cubed plus 2x squared minus 7x plus 4 over the big denominator that we had, which was parentheses 2x minus 2, then x squared minus 4x plus 3. Now, I'm going to try and see if I can take the greatest common factor or grouping. Yeah, I will have to group the numerator. So I'm just going to go ahead and rewrite it down here. X cubed plus 2x squared minus 7x plus 4. So I'm going to group. I'm going to take out an x squared. So we're left with x plus 2. I'm going to take out only a negative. There's really nothing I can take out on this other one. Now there's nothing I can take out from this one, so we're just kind of leaving it there. I'm going to go ahead and distribute the denominator, see what happens. But I'm going to leave this part kind of on standby, just kind of erase it for now since there's nothing I can do with it yet. I'm going to go ahead and work on the denominator then. I'm going to go ahead and distribute the terms. So we're going to get 2x cubed minus 8x squared plus 6x minus 2x squared plus 8x minus 6. I'm going to go ahead and combine like terms. So I get the 2x cubed as the only cube. I'm going to go ahead and combine the squares, which is going to be negative 10x squared. I'm going to go ahead and combine the x's, which is going to be 14x. Then I'm left with negative 6. I'm going to attempt to group, see what happens. So I can take out a 2x squared to get x minus 5. And then I'm going to take out a 2 on the other one. So I get 7x minus 3. All right, so that's what I get for the denominator after grouping it. I'm going to open a new slide so we can rewrite it grouped. And I'm going to group again, or factor again, the top like we did before. That way we can see if by any chance when we group or separate the terms, we'll get something that's similar. So I have the top as x cubed plus 2x squared minus 7x plus 4. In the denominator, after grouping it, I get 2x squared x minus 5 plus 2, 7x minus 3. The reason I'm not combining it is because at the very end, they have to be the same terms. So I can't just combine the two parentheses, so that's why I'm leaving it the way it is. Now I'm going to group again the top like we did earlier. See if there's anything by chance that would match. To get out an x squared, to get x plus 2. And then in the other one, I said I took out a negative, so I was left with 7x minus 4. I'm going to rewrite it just on top and the bottom to see if there's anything that we can simplify. There might not be anything to simplify, but it's always worth a shot trying it out, because the smaller the answer, the easier at the end it's going to be. It's not always going to be perfect. Okay, so there's absolutely nothing we can cancel out. So I'm just going to go ahead and rewrite it as we had it before. So the numerator as x cubed plus 2x squared minus 7x plus 4. And the denominator as 2x cubed minus 10x squared plus 14x minus 6. Since there's nothing to simplify that we can do with grouping or greatest common factor or any other term, this would be the final answer that you would leave. You can leave it as this either way. Either way is fine, as one is just more factor than the other. These two are at the end the same thing. I just sometimes, if I can't cancel anything out, I prefer leaving it as one big term instead of a lot of parentheses. Makes it nicer to see, but either way, either answer would be fine. So for number 5, they want you to find the least common multiple of 5x cubed and 10x squared minus 15x. Now, since there's nothing I can take out from the first term, I'm going to go ahead and try and factor the second, see if there's anything that's common. Now I can take out a 5x for both of these. So I'm left with 2x minus 3. And here, if you can think about it, this is 5 times x times x times x, because we have 3 x's. So our actual least common factor is 5x, because that's what we have common for both of them. So you can actually factor this one out if you want as 5x times x squared, if you did not see that it was 5x times x times x. So our least common factor for this one is 5x. Now for 6, 7, and 8, they want us to find the sum or the difference. So I'm going to go ahead and cross multiply like we have been doing. So I'm left with 3 times 7 minus 1 times 4x. And then 4x times 7. I'm going to go ahead and do 7 times 3 is 21. Then minus 4x over 28x. I'm going to rearrange this into standard form. So I get negative 4x plus 21 over 28x. Now, there's nothing I can take out from the top to simplify this, neither from the bottom. So this is actually your final answer. Now for number 7, I'm going to go ahead and cross multiply. Now I'm not going to write 1 times 9x squared minus 12 because it's just going to be the same thing. So I'm just going to go ahead and write 9x squared minus 12 plus x times 3x squared. All of that over 3x squared, 9x squared minus 12. I'm going to go ahead and now multiply both of the terms, the numerator and the denominator. So I get 9x squared minus 12 plus 3x cubed. I'm going to go ahead and distribute the denominator. So that's going to be 27x to the 4th power minus 13 times 12. Sorry, not 13. 3 times 12. So 36x squared. I'm going to rearrange the numerator into standard form. So I get 3x cubed plus 9x squared minus 12 over 27x to the 4th minus 36x squared. I'm going to take the greatest common factor, which in the numerator is actually 3. So I'm left with 3 parentheses, x cubed plus 3x squared minus 4. And at the bottom, I'm pretty sure it's also 3 for the greatest common factor, 3x squared. Now, if I'm wrong, I'm going to still be able to take something else out. So it's not the end of the world if I don't take out the greatest common factor right off the bat. Now, 27 and 3 is 9x squared. And then we have 36 divided by 3. That is 12. Now, you see, I could have taken out another number. Did not know that. So I'm going to take out another 3 for the denominator. So I'm just going to rewrite the numerator. I'm going to take out another 3, so it's going to become 9. It's going to become 9x squared. And then in the inside of the parentheses, it's going to be 3x squared minus 4. Now, because we have a 3 and a 9 on the outside, I can actually end up simplifying those. So the answer so far is x cubed plus 3x squared minus 4 over 3x squared minus 4. Now, that is our final answer, as there's nothing else you can really do for it. The reason I don't cancel the 3x squared minus 4 on the top and the bottom is because it's not a multiple. The top term is being added while the bottom one is being multiplied. You have to make sure it's everywhere in order for me to be able to cancel it, which is what I did with the 3 and the 9, as it's being multiplied by the entire term in the top and the entire term at the bottom. So this is the answer for 7. Let me mark this one 6. Let me mark that this one is 7. All right, so this new slide, I'm going to write in question number 8. I'm going to copy it from the last page so we have it as x squared minus x minus 12 plus 5 over 12x minus 48. Now I'm going to go ahead and cross multiply like we've been doing. So I'm left with x, 12x minus 48 plus 5, x squared minus x minus 12 over x squared minus x minus 12 times 12x minus 48. Now we're going to have to start distributing and combining like terms. I'm going to start with the numerator because I don't want to touch the denominator yet. So in doing that, I get 12x squared minus 48x plus 5x squared minus 5x. And 12 times 5 is 60, so we get minus 60. I'm going to go ahead and combine like terms. I'm not going to write the denominator quite yet. I'm just going to work on the numerator. Let's start with the square. So 12x squared and 5x squared is going to be 17x squared. Now we have 48 and 5. So 48 and 5 is negative 53x. And then I'm left with 60 because there's no other term. Now for the numerator, there's not a lot we can do. We can try and factor it out. 17 being a prime number, we're going to end up with 17 in one parentheses and 1 in the other. So for the first time in all the examples, this numerator actually simplifies to 17x and then x in the other one. I was looking at the factors of 60 on my phone, and I got the factors that would work as positive 15 and negative 4. When I do that, I'm able to get negative 53 and negative 60, which is exactly what we're looking for. So we have the numerator. Now let's work on the denominator. I'm going to do the denominator in red right here on the side. I'm going to go ahead and distribute first and see what I get. So I'm going to go ahead and I'm actually going to distribute backwards because it's less numbers. So we end up with 12x cubed minus 12x squared minus 12 times 12 is 144. So we get minus 144 minus 48x squared plus 48x, and 48 times 12 is 576, but it's going to be positive because a negative times a negative is a positive. I'm going to go ahead and start combining like terms. There's nothing else that's cubed, so I'm left with 12x cubed together. I'm going to go ahead and cancel it out. Then I get 48 and 12 both being negative. So I end up with negative 60 x squared. Then I have the 48x by itself because there's nothing I can do there. And the 576 minus the 144. We're left with positive 432. Now I'm going to go ahead and group because we have 4 terms, and let's try it out. See what's the worst that can happen. I can take out a 12 from the first one, a 12x squared. So I'm left with x minus 5. And I can take out a 48 on the second, and I'm left with an x plus 9. Now, if I were to rewrite it into the equation, I'm left with 12x squared parentheses x minus 5 plus 48x plus 9. There's really nothing I can do here to combine it. So I'm just going to go ahead and rewrite the equation as 17x plus 15, x minus 4. And then at the bottom, I'm just going to go ahead and write it in this term before I factor it out or I try to group it into to 12x cubed minus 60x squared plus 48x plus 432. Now, the reason I'm rewriting it like this is just so it's easier to see, but you can write it like this too, and it would be fine. That would be our final answer, as there's nothing we can do to simplify this. All right, since we're done for the day, you guys do have homework, and it is on Canvas. But that's it for today's notes.